Chapter 11 discusses calculations with anticoagulants and insulin. So, anticoagulants are blood thinners, and then insulin is taken by diabetics to help regulate blood sugar in the body. So, both of these types of drugs are on what we call the high alert list of medications, and that's just because there are a lot of different types of anticoagulants and insulin, and they have to be given correctly, or detrimental effects could occur. So these medications, really the main anticoagulant this chapter discusses is heparin, which is a very common blood thinner, as well as insulin and other drugs like penicillin. They're going to be measured in international units. And it's important to note that these units are only specific to that certain drug. So, for example, 1 unit of an insulin is not going to be equivalent to 1 unit of heparin. So, specific to each drug. Um, we also, the strength is also listed as units per milliliter. So we're going to take a look here at calculating some different doses with both insulin and heparin throughout this chapter. So just like I mentioned in chapter 10, always make sure that you're reading the label, not only when you're just pulling the drug, making sure that you have the right drug, but also that the dose that you are conveying on the SIG is correct for the patient as well. So when we're talking about insulin, most insulin comes in what we call U100. Now you need to know that U100 means that there are going to be 100 units in every 1 milliliter of the insulin preparation. Now, most insulin is U100, but there are others to be aware of. We can have U200, U300, and U500. But most of the time, the insulin that we're going to have to, have our patients draw from a vial is going to be U100. It's also important to remember that insulin syringes should only be used to measure insulin. The only other type of syringe that we could use besides an insulin syringe to measure out U100 insulin would be that standard 1 ml tuberculin syringe, and that's because it measures to the nearest hundredth. And we'll take a look at an example of some insulin calculations here in just a little bit, in which you could use that 1 ml syringe. So if you are looking at page 218 at the bottom here, I have highlighted this section because it is very important. So we can have both regular insulin and NPH insulin. So if you ever see the abbreviation for R insulin, that just means regular. Regular insulin is a clear solution and it is short acting. Now we can also have NPH insulin. So if you ever see an N abbreviation, that is standing for NPH. NPH insulin is a cloudy suspension that is intermediate acting. So it's not working as fast as regular insulin. So it has a slower onset, meaning it takes longer to start working, and it has a longer duration of action. So it's going to work longer in the body. Okay. Now, here's an example of just a few different types of insulin labels that we see. So we have Humalog, Humulin R, Humulin N, and then Humulin 7030, which is actually a combination of both regular and NPH insulin. So you can see that these Humulin labels especially look very similar. So we can see how easy it would be to pull the wrong drug, which is why reading those labels is very important. Also, another very important concept here, all insulin can be given subcutaneously, but only regular insulin and some newer rapid acting insulins can be given via IV. Okay, so all insulin can be given subcutaneously. Only a few different types can be given intravenously. If you ever have a case in which a patient has to, or a nurse, has to draw up two different types of insulin, say we need to combine both regular and NPH, one must be clear, either short or rapid acting, so like a regular, and then the other a cloudy, longer acting. So like if we were adding a regular to an NPH in the same syringe, we would always have to draw up the regular or the clear insulin before the cloudy insulin as well. So if we were doing regular and NPH, it would go regular and then NPH into the syringe. Another example of two very common insulins that we dispense, Lantus and Levemir. Both of these are long-acting insulin, so they're not either regular or NPH. They're long-acting, and they should never be mixed with any other type of insulin. I went ahead and printed out this page for all of you, so you should have a hard copy of this. It's also directly out of the book on page 221 here. So I would like you to hang on to this, really start studying the different types of insulin. So like I just mentioned earlier, I just discussed regular and NPH, but it's important to know that we have rapid acting, which starts working within 15 minutes, all the way to ultra long acting, which usually takes an hour to start working, but it's going to work for up to 42 hours or more. So someone on Tresiba, for example, they would not have to give themselves, or if it's a nurse, give that insulin, very often at all. And then down at the bottom of the table, you can see some of those combination products. So things like Humulin and Novolin, as well as Humalog and Novolog. We have different combinations here, basically just the ratios of regular to NPH insulin for these three up here. And then these two are, this one is NPH and Aspart, and then NPH and Lispro. So we're going to start discussing some of these drugs within the top drugs each week, but start memorizing this table now. There's not going to be any questions on the exam over this table, but this exam, or sorry, the certification exam, you will be expected to know the different types of insulin and then the common ones that fall under each category here. So we're just going to take a look at practice problems A. So for all of practice problems A, you're going to be using these labels here that you see on page 222 and 223. So these labels, as well as these syringes here, that's what you need to refer back to for all of practice problems A, okay? So let's just take a look at number 1 here. A physician orders Humulin N insulin, 45 units subcutaneously to be given every morning. Says which vial of insulin should be used for this order. Well, we can see that the drug that's being ordered is Humulin N. So we just want to look at these labels. Well, that's Humalog, that's Humulin R. So Humulin N is what we need. So the vial that we need would be vial C. So vial C. Now, which syringe should be used to supply the most accurate dose? Well, we need 45 units each time. So if we look at these syringes, we have a 30-unit syringe. Well, 45 units would not fit in there, so we would not choose A. And then we have a 50-unit syringe and a 100-unit syringe. Now, 45 units would fit in both of these, but it says which would give us the most accurate dose. Now remember, the smaller the syringe, the more accurate it would be. So we would choose B in this case for the type of syringe that we need. Now, let's say that we did not have an insulin syringe. So all we had was a 1 ml tuberculin syringe. So the way that we could figure out the dose volume to draw up would be to set the strength of our insulin equal to the order. So how we always do. And if you look at this Humulin N label, you can see that it is a U100 insulin. So now U100, remember, means that we have 100 units in every 1 milliliter. So in this case, if we needed to draw up 45 units, we could set that equal to our strength and then just solve for x to give us our dose volume. So here we have 100 times x gives us 100x equals 45 times 1, which is just 45. Now to get x by itself, divide by 100, divide by 100 here, and then x would equal 0.45 milliliters. So if we had to use a tuberculin syringe, if we did not have a syringe that measured in units, we could actually draw up 0.45 milliliters, and that would give us 45 units of insulin. Okay, so I'm taking a look at number 9 on page 225. So here we have an order for Humulin 7030. They want 30 units. And then Humulin R, we want 22 units every morning. So when you're looking for the vials and the syringes, make sure you refer back to those labels that we looked at earlier. I'm not going to go through those questions here. You should be able to solve for those relatively easy. What I wanted to focus on were these 2 questions here. So this first question says, how many units of regular insulin would a patient receive per day? Okay, so this little note here is very important. 70/30, in this case for the Humulin 70/30, means that in each dose of insulin, 70% is NPH and 30% is regular. Okay, so if we're looking for units of regular insulin that they're receiving per day, we're going to have to look at both this Humulin 70/30 units and this Humulin R 22 units. Because remember, R means regular, and then 30% of these 30 units is also regular. So we know that from this vial, we're already getting 22 units. So I'm going to write that over there just so we don't forget about that, okay? So now we need to figure out how much of this 30 units is actually regular. So if we have 30% of this is regular, we're basically taking 30% of 30 units to figure out how much would be regular. Now, looking back on the rules that we learned when we were talking about word problems, anytime we see of, that's going to tell us to multiply. So we're really going to take 30% times 30. Now to make this easier for us, we always want to change our percentage into a decimal. So remember, going from a percent to a decimal, you either divide by 100 or you move your decimal 2 places to the left. So 30% is the same thing as 0.3. And we're taking that times 30. So that's going to tell us how much of those 30 units is actually regular. So 0.3 times 30 gives us 9 units of R. That is directly out of these 30 units. Now remember, we're looking for the regular that they're getting in a day. So we need to add those 9 units to the other 22 that we're adding. So 9 plus 22 gives us 31 units of regular insulin. So that's how much they would receive per day. Now, the second question says, how many units of NPH insulin would they receive per day? Well, we know that this vial is strictly regular, so we don't need to worry about that anymore. And we know that 70-30 means that 70% is NPH. So we could take 70% of the 30 units to find our NPH. So once again, change this into a decimal first. So 0.7 of tells us that we need to multiply. And then now we can solve. So 0.7 times 30 gives us 21 units of NPH. And that makes sense because out of these 30 units that we're using, we said 9 of them were regular. So 30 minus 9 means that there would have to be 21 units left. So we really didn't even have to solve it this way, but I wanted to show you how we can do that if we hadn't already solved for the units of regular here. So always just take your percentage times the total amount that you're adding from that vial. Okay, so once again, anticoagulants are blood thinners, so they're going to reduce the chance of blood clots. So heparin, like I said, very common anticoagulant that's used, and you can see that it is available in a lot of different strengths. So available all the way from 10 units per mil all the way to 20,000 units per mil. So if you weren't looking and you accidentally grabbed, 1,000 unit per mil instead of a 10,000 or a 10,000 instead of 1,000, you could potentially, inject or have somebody be injected with up to 10 times more of a dose than was actually needed. And, if that's a blood thinner, that is, going to lead to a life or death situation if we're not able to reverse that, very quickly. So it is of utmost importance that you are always verifying multiple times the label that you're, the label of the drug that you're pulling and verifying with the actual order multiple times throughout the filling process. So heparin itself can be used as just a simple flush for an IV injection site to keep it patent, which just means keeping that open. So for those flush injections, we're probably going to use a really small strength there. We would not want to, inject very much at all either. It can also be used as an IV infusion additive or as a deep subcutaneous injection into that fatty subcutaneous tissue. So make sure that you're aware of, the different routes of administration and uses for heparin as well. Also, we always measure heparin in the 1 ml tuberculin syringe. So once again, we can measure to the nearest hundredth with that syringe. I also wanted to draw your attention to this tech alert in the book. So heparin is never administered intramuscularly because of the danger of bleeding into the muscle tissue. So once again, sometimes it's given subcutaneous, sometimes it's given intravenous, but never given intramuscular. Okay, I am on page 231, taking a look at number 9 here. So a physician orders heparin 7,500 units stat. We have in stock a 10,000 unit per mil vial and a 20,000 unit per mil vial. They both have a total of 1 mil in them. So it says, which strength of the medication can be used without rounding the dose? Well, the first thing we're going to have to do is figure out what volume we could draw out of each of these to give us our 7,500 units. So just as in any other calculation, we always set the strength of our drug equal to the dose. So let's start with this 10,000 unit per mil. So we have 10,000 units in every 1 milliliter, and we need 7,500 units. So we're going to solve for the volume that should give us that amount. So we have 10,000 x equals 7,500. We need to get x by itself. So we divide by 10,000. So 7,500 divided by 10,000 gives us 0.75 milliliters. So if we chose A, that would be the volume we need to draw out. Now we want to do the same thing here with the 20,000 unit per mil vial to figure out what that volume would be. So here we have 20,000 units per 1 milliliter. And we're going to set that equal to our order for 7,500 units over X. So we have 20,000 X equals 7,500. We divide by 20,000 here. Do the same thing here. So now if you plug that into your calculator here, 7,500 divided by 20,000, that gives us 0.375 milliliters. So the question says, which strength of vial can be used without rounding the dose? So remember, heparin is measured in a 1 ml TB syringe, and those syringes we can round to the nearest hundredth. So we have the two options here. We have 0.75 mils and 0.375 mils. Well, this one is already rounded to the nearest hundredth. Here, we would have to round to 0.38. So we would want to choose this dose because it avoids rounding and it's going to be more accurate. So remember, that was from the 10,000 units per mil vial. So we would choose vial A. And then it says what volume of the chosen medication should be given. Well, we solved for that already. So we would need to give them 0.75 milliliters. Now, on your assignments, like I mentioned earlier, when you have syringes to draw on in the book, just skip those. You don't have to try to draw those out on your paper. But I did want to show you here, if we're looking at this 1 mil syringe, we have 0.6 mils here, 0.8 mils here. So 0.7 would have to be right in the middle at this hash mark here. So 0.75 would be in between those two right here. So if we were drawing that up, that is where we would draw to on our syringe. Now, like I mentioned earlier, we're going to have, a lot of practice with this in the actual lab, drawing up these syringes physically, so you don't have to worry about filling out those syringes in your assignment this week.